finding things. One more thing we need to talk about today is Doppler effect. Who can explain to me what Doppler effect is? Does anybody know what that is? And have we heard of Doppler radar? Okay. How does Doppler work?
Oh, doesn't it like show like an increase in like what is happening and everything?
Kind of.
Like submarines use it in the water.
They use sonar, but it's very similar to that, yes.
It's all about what they can
Take a look at this image right here. What does that tell you?
Force.
What's happening in this region
do.
versus in this region?
Well, the lines are getting like closer together.
Yeah, they're getting compressed, right? Okay.
Well, that's why when you drive by, like, are blaring the horn, and like, if someone else is doing it too, like, it sounds like it's getting high. It sounds like it's changing pitches as it's closer.
There you
it's
go.
not.
Yep. That's the more that those sound waves get compressed, the higher the pitch. Okay, so if you guys ever heard an ambulance or a police car drive by with the sirens on, it gets really, really loud when it's right next to you. And then, I mean, if I'm from here to the door, what about halfway through the room? It gets really, really loud, and the second it passes me, it's like you can't even hear it anymore. And that's because of the Doppler effect. As it's coming towards you, it's compressing the sound waves between you and that vehicle. And as soon as that passes, the sound waves are no longer getting compressed, they're being elongated. And so therefore the pitch lowers to the point where you can't even hear it anymore. The Doppler radar works exactly the same way. It sends out these radio waves, and it bounces off material.
Like that.
Okay? And so you can see this little speck right here, and this little speck. So it picks up on these tiny little droplets of water. And what happens is it can actually tell. And it's doing this all the time, and he's sending out these messages. So then it's saying, all right, is the time that it's taking for my wave to come back to me, is it lengthening, or is the time shortening? If it's shortening, it means it's being compressed and it's coming towards you, which is the green. The red is if it's moving away. So all of this rain that you see through here, what does that actually tell about what's happening? Which way is the air, which way are those droplets moving? Okay. Now, if you ever watch the news and we think we've got a big thunderstorm in our area, what are they constantly looking for? They're worried about rotations. You get a rotation within a storm, what does that tend to produce? Tornadoes. And so what they're looking for, Doppler radar, is what allows them to see if that storm is rotating. And by modeling that. Now it's kind of interesting, remember we talked about with direction and speed. Green is coming towards you. Red's moving away from you. And then the brighter the color, the faster it's moving. What do you guys see right here and right here? It's like a straight line, isn't it? What do you think those individual points are? They're cars. The Doppler radar simply picks up material. It doesn't pick up that it can't differentiate between a water droplet and a car. And so what you actually see out of this radar, you see the cars moving away from the city and the cars coming toward the city. So you actually have two major expressways here, I-55 and I-57. It's kind of cool with Doppler. All right. Last thing I want to talk about today, I thought we'd have more time. So that is weather station models. We're actually going to do an activity with this.
So what do you want us to put down for the Doppler effect?
Is actually how most meteorologists actually model weather. We don't really do it with the big weather maps. That's more for places like Weather Channel or something like that. Most of what's really done is we take these collection of weather stations and then compile our data from there. And so what I want to point out to you is that this is what a typical station would look like. But what I want you guys to really notice here is that each one of these things on this model mean something. So first, I want you to look at this number 20. What does that represent? Look at page 915. What does that number 20 represent? Temperature. What about the 19? That's dew point. And what's the 188? Oh, that's your pressure. All right, negative 12. What does that mean? Okay. It's the change in pressure over what time frame? 3 hours. Okay, what does that tell you? What happened to our air pressure? If I change negative 12, what does that mean? It had dropped 12 points. So where was it before?
12 points above what it is now.
Well, if it's currently 188, it would be at 200, okay? What does that tell you? If I'm dropping that much barometric pressure in 3 hours, what does that tell you? Storms are coming. Very good. What does this little dot tell you? That tells you your precipitation. In this case, the precipitation is rain.
It's a star.
Star is snow.
Oh, there's a.
Yeah, there's a whole chart of those. All right, what about this line? What does that tell us?
Wind direction.
That's your wind direction. And what about each one of these bars? No? That's your speed of the wind. Each one of those full bars,
Oh, those bars.
each one of those full bars is, I can never remember that. I want to say it's 10 knots.
13, 17. Well, are those equal? If
Yes.
they're equal, then it's 18, 20. It's a little bit shorter.
Right here, 8 to 12, so we'll say 10 knots. A full line is 10 knots. Again, if you look at that page down there in the second column, it kind of gives you what it actually looks like there. If we have a flag, we're going very fast, right? So, based on that, I want you guys to help me out here. Here's your model. What is my temperature? 82 degrees. What's my dew point? How much cloud cover do I have?
3/4.
3/4, so you would say mostly cloudy? So the more that's filled in, the more cloudy it is, right? If it's completely covered in, we would call that overcast, right? All right, what's my current weather? Thunderstorms.
Why? Oh.
What's my pressure? 115. And what is my wind speed and direction?
23 to 27.
23, 27. In what direction? Southeast. What does that mean? What direction? When I say wind direction, what is it again? What does that mean? It's where it's coming from. Okay, so it's coming out of the southeast at 27 or 23 to 27 knots.
Wait, so if the bars were on the other side, that would be
Out of the northwest. So when we talk about wind direction, it's the opposite of where it's going, it's where it's coming from.
so wherever those bars are pointing, that's where it's coming from.
Yes. Alright, we kind of got that down? Okay, good. We'll go ahead and skip that. We'll call it quits here. Alright, what I'm going to do next, I'm actually going to have you guys look at some examples. And you're going to, again, give me this information. Right here, we're going to fill in this information here based on some more models. And then I'm going to have you guys look up old models from last year and see if you guys can give us some information. Okay? So that's what we'll be looking at here at the end of class, and I'll have homework for you guys to work on after that.